Welcome back to Max with RP. Today we are going to be solving some problems involving integration using the technique of substitution. Look at the following problem. Integral of 1 by x log x into log of log x. Dx. Okay. Now I am going to put log of log x as t. Then differentiating both sides, I will get 1 by log x into derivative of log x, which is 1 by x, dx equal to dt. So 1 by x into log x dx will become dt. So I will become, when you make the substitution, it is integral of dx by x log x dx is dt. So dx will become dt and log of log x will become t. Dx by x log x becomes dt and log of log x is t. So this is integral of 1 by t is log mod t plus c, which is log of what is t? Log of log x. Log of log x plus c. So making the right substitution helps us to simplify the problem and the process of integration becomes much easier. Integral of cot x into log sin x. Integral of cot x into log sin x dx. See, in your mind you should also know that if I take log sin x as t, then in your mind you have to first differentiate that. What will I get? 1 by sin x into cos x, which is cos x by sin x, which is cot x. So it will work. So first intuitively in your mind you should know what you should take as t. So I am going to substitute log sin x equal to t. Then what happens? 1 by sin x into derivative of sin x, which is cos x dx becomes dt. So cot x dx equal to dt. So I becomes integral of cot x dx is dt, log sin x is t. So t dt. Integral of t is t square by 2 plus c. Integral of x power n is x power n plus 1 by n plus 1. Now substituting back for t, you will get log sin x the whole square by 2 plus c. So are you able to follow how by substituting log sin x equal to t, it is possible to integrate this function because the derivative of log sin x will be cot x dx. So that is what is the technique which is involved in using this particular substitution to integrate. Look at this problem. Log of I equal to log of cosecant x minus cot x by sin x dx. So I am just going to try, okay. I am going to take log of cosecant x minus cot x equal to t. Then what will I get? Differentiating 1 by cosecant x minus cot x, okay, into derivative of cosecant x is minus cosecant x cot x. Derivative of cot x is minus cosecant square x, so plus cosecant square x dx equal to dt. So minus cosecant x cot x plus cosecant square x by cosecant x minus cot x dx is dt. Now I will be equal to, okay, can I, what is common in the numerator? This is cosecant x. So if I take out cosecant x, what will I get? 1 cosecant x, here it will be minus cot x dx by cosecant x minus cot x equal to dt. So cosecant x minus cot x gets cancelled. Therefore cosecant x dx equal to dt. So I equal to integral of, what is cosecant x? 1 by sin x. So 1 by sin x dx will be dt. So 1 by sin x dx is dt. What is log cosecant x minus cot x? That is what we have kept as t. So integral of t is t square by 2 plus c, which is equal to, what is t square? T is this. So log cosecant x minus cot x, the whole square by 2 plus c. Substitute back for t. This is your t. This is on differentiating. Is it clear? So substitution is a wonderful technique to resolve the given problems. Now, what should I write as t? The derivative of e power 2x will be, suppose I take t as the denominator, e power 2x plus e power minus 2x. Then dt will be, if I differentiate this, what will I get? 2 into e power 2x. Here minus 2 into e power minus 2x. So if I take out into dx. So this is 2 into e power 2x minus e power minus 2x dx. So I will be, this is dt. Therefore, this implies e power 2x minus e power minus 2x dx is equal to dt by 2. So I will be equal to, the numerator is dt by 2 by denominator is t. So which is 1 by 2 log mod t plus c, which is 1 by 2 log mod, what is t? E power 2x plus e power minus 2x plus c. So I have taken the denominator as t, numerator is the derivative of the denominator. Whenever the numerator is the derivative of the denominator, it becomes reduced to the form 1 by t dt, which is log mod t plus c, where t is nothing but the denominator. So here you recognize that the numerator is the derivative of the denominator. So that is the crucial point that you need to observe and then use the technique of substitution. Is it clear? So you have I equal to integral of e power 2x by e power x plus 2 dx. Now e power 2x, I can write it as e power x into e power x dx by e power x plus 2. Now, suppose I take the denominator as t, that is e power x plus 2 equal to t. Differentiating, what will we get? E power x, derivative of e power x is e power x, derivative of 2 is 0, dx equal to dt. So, I will now, you have to write it in terms of t. For what, this becomes dt. But what is e power x from this? E power x equal to t minus 2. So, for this e power x, it is t minus 2. E power x dx is dt. E power x plus 2 is t. This is integral of dt minus dt integral of, I can split it as two integrals, 2 into dt by t. T by t is 1, so dt. Then minus 2 dt by t. Minus 2 is a constant I have taken outside the integral. This is t minus 2 log mod t plus c. Substituting back for t, t is e power x plus 2 minus 2 log mod e power x plus 2 plus c. So is it clear? It's actually a very simple problem. If you understand how this technique of integration by substitution works. So I'm also recognizing here that the numerator is the derivative of the denominator. So why is this recognition? Suppose I take x power 10 plus 10 power x equal to t. X power 10 derivative is 10x power 9. X power n derivative is nx power n minus 1. What is the derivative of 10 power x? If I write 10 power x equal to, let us say, some u. Okay. Then taking log on both sides, x log 10 dx or ds, I am just taking log on both sides, is equal to log u. So, if I differentiate, I will get log 10 is equal to 1 by u du by dx, or du by dx is u into log 10. U is 10 power x. So, 10 power x log 10. So, the derivative of 10 power x is 10 power x log 10. So, 10 power x log 10 dx equal to dt. So, what do we recognize here? Numerator is the derivative of the denominator. So, dt by t, which is log mod t, which is log mod x power 10 plus 10 power x plus c. So, is it clear? Okay, how? Simple method of substitution helps us to integrate what appears to be a complicated function. This is x square sine power n into x cube cos power x cube dx. See, what you should understand is the derivative of sine x cube will involve cos x cube. So, first I am going to rewrite this as x square sine power n x cube is nothing but sine x cube the whole power n into cos x cube dx. Now, let sine x cube be equal to t. Then differentiating cos x cube It's an implicit function. So derivative of x cube is 3x square dx equal to dt. Sin x cube is t. Differentiating cos x cube into derivative of x cube is 3x square dx equal to dt. So I will be integral of, okay. So what is it, x square dx? So cos of x cube into x square dx will be dt by 3. So I will be 1 by 3. Okay. Now cos of x cube dx into x square becomes dt. Sin x cube is t. So you will get t power n dt, which is 1 by 3 into t power n plus 1 by n plus 1 plus c. So this is 1 by 3 into, what is t? Sin x cube. So sin x cube the whole power n plus 1 by n plus 1 plus c, where n is a constant. Are you able to follow? So here we are choosing sin x cube as t because we know that the derivative will involve cos x cube into 3x square dx. X square is also there, cos x cube is also there. So that is how you need to think and make the right choice for substitution. Now I equal to integral of tan power 4 root x into secant square root x by root x. I know the derivative of tan x is secant square x, right? So I am going to, so this is, first I will rewrite this as tan root x the whole power 4 into secant square root x by root x dx. So let tan root x be equal to t. Why? Because I know the derivative of tan theta is secant square theta. So derivative is secant square root x into derivative of root x is 1 by 2 root x dx equal to dt. So secant square root x by root x dx will be 2 dt. Secant square root x dx by root x. So this one dx into dx is 2 dt. So I will be integral of this 2 I will write here. Tan root x is t power 4. Rest of the terms becomes dt, which is 2 t power 5 by 5 plus c. So this is 2 by 5 into, what is t? Tan root x. So tan power 5 root x plus c. So as I told you, the right substitution, making the right substitution helps you to evaluate the integral. So you must be first of all familiar with the derivatives. Only then you can integrate. Only if, because integration is nothing but the inverse form of differentiation. And then you should also know what is the technique that you need to use. So one technique that we have been studying now is technique of substitution. Making the right substitution to simplify the given function to a form that you can easily integrate. Okay, so today we saw some 9 simple problems where we have used the technique of substitution to integrate. Please practice these problems. Then even if you are exposed to unfamiliar problems, then you will recognize the technique and you will recognize the correct formula to use. So if you find this video useful, do not forget to subscribe and share it with your friends. So it's goodbye for now. We will meet again in Maths with Aarti. Goodbye.